What's up? Welcome back. This is part two of building a programming language using a tree walk interpreter. So, in the last video, we built out the scanning of single and double character tokens. So, we're talking parentheses, braces, different symbols, equal signs, that kind of stuff. In this video, I'm going to move on to identifiers, numbers, that kind of stuff. And let's just go ahead and jump into it. And remember, you're required to vibe. Not required to code, but you are required to vibe. Listen to whatever music I decide to edit in later if you don't code. All right, so let's show screen. Cool. All right. One thing I forgot in the last video was for comments. So I'm checking for a new line character, but if we hit the end, it won't know to stop in case you don't put a new line at the end. So we also have to say while not is at end. So this will say keep going until either we hit a new line or we hit the end of the file. All right. Now, next thing we need to, we're gonna do identifiers first. So, identifier in this language and most languages is something that starts with a letter or an underscore. So, we are going to check for that. So let's see. So we're going to say if is alpha, which means if the current character is a letter or an underscore. That doesn't exist yet. And then we are going to pass in C, which is the current character. And then else, we're going to throw this error. So I'm going to go ahead down here, create a function is alpha, which will be a character, and we're just gonna return Boolean. So to check if it's alphanumeric, all you have to do is check if it's an ASCII character between A and Z, and then capital A and Z, and then also if it's a letter, an underscore. So we're going to say is less than or equal to C, is less than or equal to Z, or, and then the robots know, or C is equal to an underscore. Okay. So that's really all you have to do for if something is alpha. What is the, oh, I put car instead of C. All right, what is the, adjacent operators are a non-associative precedence group. What the hell does that mean? You know what? I believe Swift actually, yeah, it just, okay, if it was C, then I would have done it like that. But Swift actually has a helper function that if it's a letter, it will return true. And then they say if it's a letter or it's an underscore. Cool. While I'm here, also gonna one for is a digit as well. Turn C is number. Cool. And then we're also gonna need is alpha numeric, and that will be just if it's alpha or it's a digit. Okay, so now we have that. Then we know it started with either an underscore or a letter at this point. So we're gonna create another helper function for an identifier. So if it is, so we're gonna call that, and what identifier is gonna do is it's going to move on through the letter until we hit a space. Once we hit a space, we're gonna stop. Or a new line. So I also need a start position. So start index. So, and then start is just gonna also equal source dot start index. So this is where the identifier starts, and then from there we're just gonna it's where the identifier starts, and then position is where we goddamn I'm losing my train of thought. Position is where we currently are. Start is where the last identifier started. So all right, so boom, we're gonna say start equals position at the beginning of scanning the token. That way we know where this identifier started at. And the reason we need that is once we hit here, we're gonna say while is alphanumeric. So the is alphanumeric is useful because an identifier, while it needs to start with an alphabetical character and underscore, it can have numbers in it. It just can't start with a number. So we can just say while is alphanumeric and not at the end of the file. We're gonna keep calling advance. So once we hit that, so once it hits a space, it will stop going. Or if it hits a symbol, it will stop going. So boom. And now we can say let identifier that will equal a string that is equal to source start and then position. So this is just saying from source start, or from the start of where we save that up here, we save the first position, and each time we call advance is gonna increment position. So position will be at the end of the word, start will be at the beginning, and then we just have to create a string from that array of characters that were returned, and then we can go ahead and add a token. So token, and yep. So the type will be type identifier, and then the line will be whatever line we're on. So we're doing here just creating a token of type identifier, setting the lexeme to identifier, setting the line, and then we can append that to tokens. Okay, so let's actually write a test for this. I can't type. Scan identifier. Okay, so yes, we're just gonna say let foo equal whatever 1. So, well, actually, so we have not implemented numbers yet, so this is probably gonna fail. But so if I put the equals 1 there, so let's see how should I do this? So we're gonna keep it simple, and then have some different way or whatever. So there should be 3 tokens, let, foo, and bar, and then yeah. So we got to do a scanner equals scanner, and then we can expect scanner tokens. Token number 0 should equal yeah. And then we want to check the type as well. First, we're going to check that we have 3 tokens. So count, oops, not source. All right, tokens that count should equal not 3, 4, because we have to remember the end of file 1. And then expect dot token 0 type goes dot identifier. And copy and paste this a couple times, and then this one will be foo, b bar, and then expect scan 3 dot type in the file. Okay, so let's see if that passes. Yep. Okay, so that was pretty easy. But there is actually an issue. Because while let is an identifier, is actually a special identifier, aka a keyword. So we actually don't want let to be be an identifier. We want it to actually have its own special key. So we're gonna add that to our tokens. So yeah. So case for let. And now that will cause the test to build, but they will fail now because this is still being recognized as an identifier. So how do we check if it's a keyword? So there's a few ways we can do it. There's like a very easy way to do it is just to have a dictionary keys, which I think that's what I'll do right now, but then there's other ways. You could have like a table. So to keep this video moving and simple, I'm just gonna create a dictionary of the different keywords. So keywords equals, so it would be string token type. So let will be this. So it'll just be a dictionary, and then I'll add more as we go along, but the key is just a string, which will be the identifier, and then the case will be the actual token type. So how do we use this? So what we will do is when we get the identifier here, instead of creating the token right away, we will say, so if let keyword equal words identifier. So then we know that, or actually let's do this. Let token type. Yeah, so what we're doing is we're checking that if the keyword exists in the keywords dictionary, we're gonna set the type to that. Else we're gonna do what we were doing before. So yeah, if it does exist, then we're gonna say let token equal type, which would be token type. The lexeme will still be identifier, line will still be line, and then token dot append token. So I believe that should make the test pass now. Yep, that worked. So if we take a look at the test now, that is being recognized as a keyword, and foo and bar are not. They're just regular identifiers. Pretty simple. I will not bore you by watching me add in all the different keywords, but it's gonna be the exact same for every keyword. It's fairly simple. This is not the most memory or speed efficient way to do this. There's better ways. There's a way in the book Crafting Interpreters that does it a lot faster, but it's also a whole lot more code. And I don't feel like it because I'm just doing this for learning. I'm not trying to make an actual production ready interpreter. But if you're interested in this, I would say read that book, and then also read other books on compilers. The one with the dragon on it is a good resource. Okay, so let's move on to numbers. So I'm going to now create another test. So again, number. So we're gonna say all this stuff is always the same. I should probably move this out into like a setup function, but I don't feel like it. So let's see, 12, 243, 456, sure, and then 1. Right now, I'm just gonna check for integers. Actually, no, I'm going to actually check for doubles as well. So 2.5 and then 2. Yeah, right now we're just gonna do integers and floating point numbers just to keep it simple. So for our expectations, first we're gonna expect that scanner.tokens is equal to 1, 2, 3, 4, 5, 6, 7, because I did not forget the end of file 1. And then second, we're just gonna go through each one. Tokens. It would be probably good if I created some helper functions for this. But again, don't really care about making the code good right now. We're not trying to like prematurely optimize things, you know. Also, I think I'm going to separate the numbers into two different types, int and float. I think that's all I'm going to support at the moment in this project. But obviously, there's lots of different kinds of numbers. So first one is 12, and then type will equal dot integer. That doesn't exist yet. I'm going to add it, and then it's gonna update all of these. 243, 456. These numbers have no significance. I'm just putting random-ish. Okay. I feel like that's probably the best way to test things is just put random stuff and try to hit as many different possible issues in your code. Okay, so, all right, the only issue I see is one, we gotta actually access the correct numbers in the array, and then we need to add our in the file, which will be position 6, and then we have to also add these to our token case statement. So I'm just gonna replace number with and also add float. Okay, so we have floats, we have integers. So to check for a number, we're gonna say else if digit, and then create a function called number, and it's gonna be very similar to the identifier method, except that there's not gonna be anything for keywords because those don't exist. But so we're gonna say while is digit, we are going to keep going, and because we want to check for both floating points and integers, we have to say if peak equals a dot, then we're gonna advance one and then continue to do the same thing. So a little bit of there's a lot of nesting, but it's okay. So we're gonna say if peak equals a dot, advance one, and then while it's still a digit, we will keep going, and from here we will say let number equal. We're just gonna save it as a string. I'm gonna convert them into actual numbers later. So we're gonna say this, let the number equal that, and then we're gonna say if number contains a dot, we will create a float, and then else we will token be an integer, and then in both cases we have to append. Okay. All right, we're gonna just run the test, see if it passes, and it does. Cool. All right, pretty easy. Let's see, what else would I possibly need to implement in the scanner? So, all right, we got numbers. We got, oh yeah, we gotta do string literals as well. We have number literals. We will finish up the reserved words, and I believe after that we're good. And then we have to also deal with the fact that semicolons are optional. In the book, he does not make them optional, but I want them to be optional because what year is it? Okay, so for string literals, we're gonna, I hope you're getting used to this, we're gonna write another test. So scan string, and somehow it knew what the hell I wanted to do. All right, so honestly, like, the AI sometimes can be smart, but it's always like slightly wrong. It's like, yeah, see, look at this. So I'm actually gonna do something a little bit diff. So let r equal string. We have to have backslashes in the string, because otherwise we will not. We have to escape the quotations because the compiler will get confused. So that's what those backslashes are. So token. So I'm actually gonna ignore all this stuff, and so this will be position 0, 1, 2. So the fourth thing token should be the string. So that'll be position 3, and Lexeme should equal hello world, and then type equals string. Okay, so and then we need to actually add that to our token. So we have a token case, so that should cause them to build. Actually, I do want to do an expectation for the amount of tokens, so it'd be 1, 2, 3, 4, 5. Cool. I'm not gonna keep writing tests for the end of file token because we've tested it like 4 times. I think we're good. Okay, so that should build, but it'll fail. Cool. All right. So to recognize a string, we have to check for a quotation mark. So we're gonna just add that, a case for that. Go. And then just gonna have another helper method called string. So I will add that below number. All right, so as the AI was saying, if you caught that, we have to advance 1 because we want to go past the quotation mark, and then we want to start advancing until we hit another quotation mark. So we're gonna do advance. That'll put us on the first character of the string, and then we will do a while peak is not equal to quotation mark, and it's not an end. We're gonna advance, and then we're gonna say let string equals not this. So the start will actually be where the first quotation mark is, and then the end will be where the second quotation mark is. So we actually want to do source index after start, and then up until source index before position. So the source after start, or the index after start and the index before position, and that will allow us to create our token. So that equals token of type string. The Lexeme will be the string, the line, append tokens. So we're gonna run our tests, see what happens. Okay, so we finally got an error. Let's see. Index out of bounds. Okay. Let's see. Let's print out source, and then, or actually let's print source at start. Let's see what at start is the first quotation, and then position. Okay, so position is out of bounds right now. So let's see. Okay, I believe it is because we hit the end of the file. So okay, so that's a weird. It's not weird. It's not a weird bug. It makes sense. So I believe the issue is that we hit the end of the file. The position kept going until it got here, and then I think it advanced one more time, and that's why we're getting an index out of bounds. Let me take a look at the book again. See how he handles string literals. Oh yeah, I also did forget that. I guess strings can be multiple lines. Well, oh, okay, so here's the issue. We want to throw an error if we hit the end. Yeah, okay. So it is just while peak is not equal to a quotation mark and is at end, and then so if is at end unterminated string, we can actually add that to our errors up here. Okay, so that doesn't necessarily fix our problem, but it is something that we need to think about. So he's allowing multiple line strings. I guess we could go ahead and allow that. Yeah, so sure. Actually made it lowercase. I think the error should be whatever. I'm just gonna leave it lowercase. Okay, so function throw try. So this is still gonna fail. Okay. but it should fail for a different reason. So yeah, we're hitting unterminated string here because we hit the end of the file, I guess, before. Yeah, and then I actually do want to throw another advance on there for the closing one. Oh, okay, maybe I don't need this first advance now that I'm thinking about it. Okay, yeah, I just had that, I had advanced in the wrong place. So, okay, so the issue with that bug is we had already advanced past that first quotation mark. So I didn't need it up there. I need it at the end where the second quotation mark is. Okay, well that passes. Yes, now we are recognizing strings. Looks like I'm about at 40 minutes on this video, so I do just probably want to finish up the scanner. So, okay, so actually I'm realizing something. So in order to have implicit semicolons, we actually need to save the new lines as a token. So I'm actually going to add that to our thing. So whenever we hit a new line, we're going to say add token, new line. Okay, so now we have added new lines. That might possibly make our code. Yes, it did, because we're having multiple tokens here. So this changes to 15, and then after the comment, we should expect a new line now. I chose the stupidest way to do this, because now if I add another one, I have to increment all of these. I should have just made an array of the stuff. I will probably refactor this later, but whatever, bruv. We're just gonna 6, 8, 9, 10, 12, 13, 14. All right, now that passes. So now we're recognizing new lines, saving those in the tokens. So if we go ahead and run this on the command line, now we can recognize different tokens. As before, we could recognize those, but say I add like semicolon here. As you can see, we're printing out, I'm blocking this actually. Let's move me up here. So we're printing out the tokens in the array. So if I do hello or hell, it'll give us a string. Lexeme hell 12. That'd be an integer, 12.2. That's a float. As you can see, things are working pretty well so far. Wrote some tests, which I think has made this go much smoother than my emulator. Maybe this will convince me to write some tests for my emulator. But as always, thank you so much for watching. Please like and subscribe. I will be back very soon with another video. Probably continuing the compiler. I'm having fun with that. I still have a lot of work to do on the emulator that really would not be interesting at all to watch me do. Just like going through each opcode and testing it to make sure it's correct. You don't want to watch that. I don't want to film it. So once I'm done with that, I will get back to the emulator. But for now, we're going to keep going with the compiler. And if you have any questions, leave them in the comments. I'm no expert, but I do know some stuff. But yeah, thank you for watching. I've been Maddie. Bye-bye.